In this video, we are continuing to review for quiz 4, and we'll talk about random variables. So recall that a random variable assigns numbers to the outcomes of an experiment. So of an experiment. So for example, e.g., let's say that x was our random variable. We usually use capital letters to denote them. And let's say that this represents the number rolled in a 6-sided die. So that would be an example of a random variable. So the values of x here would be any of the integers from 1 up until 6. So we also have this notion of a probability density function, and that associates each value of a random variable with its probability of occurring. So its probability of occurring. So going back to our example with the 6-sided die above, so in that above example, we could write down the probability density function. That just entails writing down the probability of each of the outcomes happening. So if x was equal to 1, in other words, if I rolled a 1, that probability is 1/6. The probability that x is 2 would also be 1/6. And I could keep going like that until I get to the last value of x, which is x equals 6. And that also has a probability of 1/6. So this is just a simple example, and it's especially nice because the probabilities are all the same. But in general with random variables, the probability density function, these probabilities that we get are not necessarily going to be the same for each of the values. So let's look at an example which says that an experiment consists of rolling a fair die until the sum of the rolls exceeds 3. So that means we're going to roll the die again and again and again until the sum of the rolls is bigger than 3. Let x, this is our random variable, represent the total number of rolls. Find the probability density function of x. Okay, so I want to begin by just noting that this means we need to write the probability of each value of x, of each thing that x can be, each value of x. So let's begin by writing down what the values of x are. So before I do this, I want you to do a mini pause and pause the video for just a minute and see if you can think about, well, what does x mean and what are its values then? 4, 3, 2, 1, pause it and see if you can write down the values of x. Alrighty, so hopefully you did that. Hopefully you paused it and thought about what the values of x are. So remember, what x represents is how many times the die is rolled. It's the total number of times it is rolled. So when I'm asking, well, what are the values of x? What that's asking is, well, how many times the die can be rolled before the sum exceeds 3? Well, we could definitely roll it once. For example, if we rolled it once, maybe, e.g., I rolled a 4. Let me even write the word roll. For example, if we roll a 4, that's already bigger than 3, and then I would stop rolling it because it's already bigger than 3. I could roll it 2 times, so that's what that 2 represents. So what would the rolls be in that case? Well, one example is if I rolled a 2 first, that's not bigger than 3 yet, and then if I rolled a 4 after that, now their sum is 6, and that's bigger than 3. So I would stop after 2 rolls. But I want to point out one important clarification here. But what wouldn't fall into the category of 2 rolls is if I rolled a 4 and then a 2. So why is that? Why would rolling a 4 and then a 2 in this order not be considered one of the ways I could have 2 rolls satisfying the conditions of this problem? Well, the reason for that is if I rolled a 4 first, that's already bigger than 3. So I would have needed to stop after the first roll. So that's why 4, 2 doesn't count here. Okay, so let's continue on with other values of x. How many, can I roll it 3 times? And the answer is yes, sure, I could roll it 3 times. Here's one example, e.g., I could roll a 1 and then a 1. So that's a sum of 2. And then maybe I do a 2 after that. That third roll brings me up so that the sum is higher than 3, so I would stop. And then I could also do 4 rolls. It would be 4 rolls. For it to be 4 rolls, it means on the first 3 rolls, the sum can't be bigger than 3. The only way to make that happen from 3 rolls is if it's 1 and then 1 and then 1. That's the only way I'm not going to go bigger than 3 from my first 3 rolls. But after I do that, then the last roll could be anything. It could be anything. And I would end up with a sum that's larger than 3. Okay, so now I have a feel for, well, how many times can I actually roll the die? Now I need to find their probabilities. So here I'm going to make a table to organize our thoughts. So I'm going to keep track of the number of times the die is rolled. That's my random variable x. And then we'll keep track of the number of successful rolls. So that's where the sum will be bigger than 3 by that last roll. And then I also will need to keep track of the total number of outcomes that I can have if I roll the die that many times. And then finally, I'll be able to write down the probability, because the probability is going to be the number of successful rolls divided by the total number of outcomes. So we'll get this started, but I think after we do a few, we'll start to get the hang of this. But before I do that, so one important thing I want to point out is, for the number of times the die is rolled, well, we know now that the die can be rolled once, it can be rolled twice. I'll eventually write a 3 and a 4. For each of these, I want to think about, well, how many successful rolls are there going to be? So I'll get it started for 1, and then I'm going to pause and let you try 2, 3, and 4 on your own first. Okay, so if I roll the die, so under 1 here, that means I'm rolling the die 1 time. If I'm rolling the die 1 time, it means I need the sum to already be bigger than 3. So what would the roll have to be? I would either have to roll a 4, or a 5, or a 6. There are 3 ways I could roll that first die to make the sum exceed 3. Okay, how many total outcomes are there? If I've only rolled the die once, well, there's 6. I could have rolled any of the integers from 1 to 6. So my probability is 3 over 6, which simplifies to 1/2. Okay, so that is how many successful rolls I have if I only get to roll the die once. So now, from here, I want to have you pause the video, and for about 4 minutes, see if you can try to find the number of successes and total number of outcomes probability for 2 rolls, and if you get done with when x is 2, then move on to 3 and 4. 4, 3, 2, 1, pause it, and try that next row. Alrighty, so hopefully you did that. Hopefully you paused it and thought about what these values would be in the next row. So now, if x is 2, I need 2 rolls. So I'm going to make a table. First roll, second roll. So I got to be careful that the first roll isn't bigger than 3. If the first roll is bigger than 3, I would have needed to stop after 1 roll. So the first roll could be a 1, it could be a 2, or it could be a 3, but it can't be bigger than that. Otherwise, I would have had to stop already. Okay, and if the first roll is a 1, then the second roll now needs to make the sum be greater than 3. So that means the second roll, the smallest it could be is 3, because then the sum would be 4. It could also be 4, because 1 plus 4 would be 5, and the second roll could have been 5 or 6. So basically, if the first roll is a 1, the second roll could be 4 possible things, 3, 4, 5, or 6. In the same way, if the first roll is 2, the smallest the second roll could be is a 2. so that the sum is greater than 3. And then anything higher than 2 for the second roll would work. So 3, I'll put comma, up until 6. And then if the first roll is a 3, well, anything that I get on the second roll would make the sum greater than 3. So I'll put 1, comma, 6. Okay, so if the first roll is a 1, there are 4 ways I can make the second roll sort of work. If the first roll is a 2, then there's 5 ways to make the second roll work. And if the first roll is a 3, there are 6 ways. So overall, I need to do 4 plus 5 plus 6, and that is 15. There's 15 successful ways to roll the die here. So how many total outcomes are there if I've rolled the die twice? Well, 6 choices for the first roll and 6 choices for the second roll, and I multiply those to get 36. So my probability is 15 over 36. And this simplifies because I could divide the top and the bottom by 3. And doing that, we get 5 over 12. Okay. So one of the things that we're doing here in this table is for each of these values of my random variable, I'm essentially just listing out all the things that make it work to find the probability. And that's helpful if there really aren't that many possibilities. And that's the case here because it tells me that the sum, ultimately I'm looking for when the sum is going to exceed 3, which means before that point, before that roll when it exceeds 3, there are only a limited number of possibilities. And that's one of the reasons why just listing them out like this is working. Okay, let's go to what if x is 3? So if x is 3, so let's make a row there. So if x is 3, now I need, let's add a third column. So first roll, second roll, third roll. So my first 2 rolls combined should not sum to something bigger than 3. Otherwise I would stop after the first 2. Okay, so that could mean the first 2 are either 1 and 1, 1 and 2, or 2 and 1. That's the only combinations so that their sum is not going to be bigger than 3. Okay, so if the first 2 things are 1 and 1, the third one now needs to make the sum be bigger than 3, which means it's got to be at least 2. So it's got to be 2, comma, up until 6. If the first 2 rolls are either 1 and 2 or 2 and 1, then the third roll could be anything. So 1 up until 6, 1 up until 6. Because no matter what it is, that sum of all 3 of them now will be bigger than 3. Okay, so in this first case where the first roll is a 1, the second roll is a 1, there were 5 choices for what the third roll could be. So 5. In the second row here, there were 6 choices, 6 ways to make that happen. In the third row, there were also 6 ways to make it happen. So 5 plus 6 plus 6, that is 17 ways. And if I'm rolling the die 3 times, total number of outcomes is going to be 6 times 6 times 6, which is 216. So my probability is going to be 17 over 216. Alrighty, so we got one more of these rows to go. So finally, what if I roll it 4 times? If I roll it 4 times, well, let's think about each of the rolls. The first, the second, the third, and the fourth. Now I have to have 4 rolls. And if I have 4 rolls, well, the first 3 can't sum to something bigger than 3. The only way to make that happen, we've seen already, is if they're all 1. And then after that, the fourth could be anything, because it's automatically going to make the sum of all 4 be bigger than 3. So this could be 1, comma, up until 6. So overall, there are 6 ways to make this happen. The total number of outcomes, if there's 4 rolls, would be 6 times 6 times 6 times 6, 4 times, which is 6 to the 4. So the probability is 6 over 6 to the 4. And that simplifies to 1 over 6 cubed, which is 1 over 216. So looking back at our table of values, one important thing that we could always do as a quick check is to make sure that these values, these probabilities, sum to 1. And if we were to test it out for all of these probabilities, because these are the probabilities of all the different values my random variable could take on, these do sum to 1. So we're we're happy about that. Okay, so this question wanted me to write down the probability density function, which means basically now just write out explicitly what the probability of each of these values occurring is. Even though I have it in table form, it's nice to just write it down explicitly. So the probability that x is 1 was, let's see, it was 1 over 2. 1 over 2. The probability that x is 2 is 5 over 12. The probability that x is 3 is 17 over 216. And the probability that x is 4 is 1 over 216. And that's all it wants when it says find the probability density function. Write down the probabilities of each of the values of my random variable.